we might have AI that is smarter than any human by the end of this year, and I would say no later than next year. Wow. And then probably by 2030 or 20.
You don't need another AI update. You need a new way to think. Because if AI really is accelerating the way these leaders believe, the question isn't what's coming. It's, will you be someone who adapts fast or someone who gets left with excuses? In this episode, I'm going to challenge you to stop watching AI from the sidelines and start building an edge. How you work, how you learn, and how you create value when the rules change overnight. To calibrate the stakes, we're starting with a prediction that's either wildly wrong or a warning you can't afford to ignore. Listen closely, not for the date, but for what it demands of you.
I don't know what's going to happen in 10 years, but the rate at which AI is progressing, I think we might have AI that is smarter than any human by the end of this year, and I would say no later than next year. Wow. And then probably by 2030 or 2031, call it 5 years from now, AI will be smarter than all of humanity collectively.
You just heard Elon Musk's timeline. Now, here's a different lens. Not just when, but the mechanism that could make progress feel like it's speeding up on its own.
Are off. So, the mechanism whereby I imagined it would happen is that we would make models that were good at coding and good at AI research, and we would use that to produce the next generation of model and speed it up, to create a loop that would increase the speed of model development. We are now, in terms of the models that write code, I have engineers within Anthropic who say, I don't write any code anymore. I just let the model write the code. I edit it. I do the things around it. I don't know, we might be 6 to 12 months away from when the model is doing most, maybe all of what SWEs do end to end. And then it's a question of how fast does that loop close? Not every part of that loop is something that can be sped up by AI, right? There's like chips, there's manufacture of chips, there's training time for the model. So it's, I think there's a lot of uncertainty. It's easy to see how this could take a few years. It's very hard for me to see how it could take longer than that. Yeah. But if I had to guess, I would guess that this goes faster than people imagine, and that key element of code and increasingly research going faster than we imagine, that's going to be the key driver. It's really hard to predict, again, how much that exponential is going to speed us up, but something fast is going to happen.
I think it's that is still my timeline. And it's a little bit longer than some others some of my peers that you'll hear. But my bar is quite high. It's the ability to, a system that exhibits all the cognitive capabilities humans have. And I think we're still clearly quite far from that. That means, in things in like scientific creativity, not just solving a conjecture or solving a problem in science, but actually coming up with the hypothesis or the problem in the first place. And as any scientist knows, finding the right question is actually often way harder than finding the answer. So it's not clear that these systems have that capability yet. In fact, they definitely don't right now. I think they will eventually, but it's not clear what's needed still. And there's things like continual learning, online learning, going beyond what they've been sort of trained for, and then they're static out in the world. They need to learn on the fly. So there's quite a few, in my view, missing capabilities that are quite critical to what I would regard as an AGI system.
We've been talking capability and timelines. Now we have to talk maturity, because power isn't the problem. The real question is whether you and we can handle what we're building.
That movie has kind of stuck with me. And that's the frame that I used, which is that we are knocking on the door of these incredible capabilities, right? The ability to build basically machines out of sand, right? I think it was inevitable that the instant we started working with fire, but how we handle it is not inevitable. And so I think the next few years we're going to be dealing with, how do we keep these systems under control that are highly autonomous and smarter than any human? How do we make sure that individuals don't misuse them, right? I have worries about things like bioterrorism. How do we make sure that nation states don't misuse them? That's why I've been so concerned about, the CCP, other authoritarian authoritarian governments. What are the economic impacts, right? I've talked about labor displacement a lot. And you know, what haven't we thought of, which in many cases, you know, may be the hardest thing to deal with at all. So, you know, I'm thinking through how to address those risks. And, you know, for each of these, it's a mixture of things that we individually need to do as leaders of the companies, and that we can do working together. And then there's going to need to be some role for wider societal institutions like the government in addressing all of these. But you know, I just feel this urgency that, you know, every day, you know, there's all kinds of crazy stuff going on in the outside world, outside AI, right? But you know, my view is this is happening so fast and is such a crisis. We should be devoting almost all of our effort to thinking about how to get through this.
Now, let's shift from philosophy to the practical reality. If this is a platform shift, you don't win by debating it. You win by building on it.
It's helpful to reason back to the first principles of fundamentally what is happening to the computing stack. This is a platform shift. A platform is something where applications are built on top of. And this is a platform shift like the platform shift to PCs. New applications were developed to run on a new type of computer. Platform shift to the internet, a new type of computing platform, hosted all kinds of new applications. A platform shift to mobile cloud. In each and every one of these platform shifts, the computing stack was reinvented and new applications were created. This is a new platform shift in the sense that today you're using ChatGPT. It's important to understand that itself is an application, but very importantly, new applications will be built on top of ChatGPT. New applications will be built on top of Anthropic Claude, for example. And so it's a platform shift in that way. AI is really easy to understand if you realize what it can do that you could never do before. Software in the past was effectively pre-recorded. Humans would type and describe the algorithm or the recipe for the computer to execute. It was able to process structured information, meaning you've got to put the name, the address, you know, their account number, their age, where they live. You create these structured tables that software would then go and retrieve information from. We call it SQL queries. SQL is the single most important database engine the world's ever known. Almost everything ran on SQL before now. Now we have a computer that can understand unstructured information, meaning it can look at an image and understand it. It could look at text and understand it. It's completely unstructured. It could listen to sound and understand it, understand the meaning of it, understand the structure of it, and reason about what to do about it. And so for the first time, we now have a computer that is not pre-recorded, but it's processed in real time, meaning that it's able to take the context of the circumstance, whatever the environmental information, the contextual information, and whatever information you give it, it could reason about what is the meaning of that information and reason about your intent, which could be described in a really unstructured way. You describe it however you want to describe it. We call it prompts. But you describe it however you like to describe it. And to the extent that it can understand your intention, it could perform a task for you. Now, last year, I would say three major things happened in AI, in the AI technology layer, the model layer. The first one is that the models themselves started out being curious and interesting, but they hallucinated a great deal. And last year, we can all reasonably accept that these models are better grounded. They could do research. They can reason about circumstances that maybe they weren't trained on, break it down into step-by-step reasoning steps, and come up with a plan to answer your question, do your research, or perform the task. So last year we saw the evolution of language models becoming AI systems that we call agentic systems, agentic AI. The second major breakthrough is the breakthrough of open models. Several years ago, was it a year ago? DeepSeek came out, and DeepSeek was A lot of people were quite concerned about it. Frankly, DeepSeek was a huge event for most of the industries, most of the companies around the world, because it's the world's first open reasoning model. Since then, a whole bunch of open reasoning models have emerged, and open models has enabled companies and industries, researchers, educators, universities, startups to be able to use these open models to start something and create something that's domain specific or specialized for their needs. The third area that had enormous progress last year was the concept of physical intelligence, of physical AI. AI that understands not just language, but AI understands, if you will, nature. And it could be AI that understands the physical world here, AIs that understand proteins, chemicals, physics, for example, fluid dynamics, particle physics, quantum physics, AIs that are now learning all these different structures and different languages, if you will. Proteins is essentially a language. And so all of these AIs are now making such enormous progress that these industrial companies, whether it's manufacturing or drug discovery, are really making great progress. And one of the great indicators is a partnership that we had with Lilly that they realize now that AI has made such extraordinary progress in understanding the structure of proteins and the structure of chemicals, essentially being able to interact and talk to the proteins like we talk to ChatGPT. We're going to see some really big breakthroughs. Remember, 10 years ago, one of the first professions that everybody thought was going to get wiped out was radiology. And the reason for that was the first AI that became superhuman in capability was computer vision. And one of the largest applications of computer vision is studying scans by radiologists. Well, 10 years later, it is true that AI has now completely permeated and diffused into every aspect of radiology. And it is true that radiologists use AI to study scans now. The impact is 100%, and the impact is completely real. However, not surprisingly, I say not surprisingly, if you reason from first principles, not surprisingly, the number of radiologists have gone up.
Is that because of lack of trust or is that because the human interaction with the results of AI is a better outcome?
Exactly. The reason for that is because a radiologist, the purpose of their job is to diagnose disease, to help patients diagnose disease. That's the purpose of their job. The task of the job includes studying scans. The fact that they're able to study scans now infinitely fast allows them to spend more time with patients, diagnosing their disease, interacting with the patients, interacting with other clinicians. Well, surprisingly, also not surprisingly actually, as a result of that, the number of patients that the hospital can see has gone up. Because, there are a lot of people waiting a long time to get their scans done. And so now, because the number of patients have gone up, the revenues of the hospital has gone up, they hire more radiologists. This is the same thing as happening to nurses. We're 5 million nurses short in the United States. As a result of using AI to do the charting and the transcription of the patient visits, nurses spend half of their time charting.
Documenting.
And now they could use AI technology, and one particular company, Abridge, they're a partner of ours doing incredible work. As a result of that, the nurses could spend more time visiting patients.
Human touch.
That's right. And because you could now see more patients, and we're no longer less bottlenecked by the number of nurses, more patients could get into the hospital sooner. As a result, hospitals do better, they hire more nurses. And so surprisingly, AI is increasing not surprisingly, AI is increasing their productivity. As a result, the hospitals are doing better. They want to hire more people. You have too many people waiting too long to get into hospitals. And so these are two perfect examples. Now, the easiest way to think about what is the impact of AI on a particular job is to understand whether the job what is the purpose of the job and what is the task of the job. If you just put a camera on the two of us and just watched us, you would probably think the two of us are typists because I spend all of my time typing. And so if AI could automate so much word prediction and help us type, then we would be out of jobs. But obviously that's not our purpose. And so the question is, what is the purpose of your job? In the case of radiologists and nurses, is to care for people. And that purpose is enhanced and made more productive because the task has automated. And so to the extent that you can reason about each one of the people's purpose versus the task, I think it's a helpful framework.
You just heard Jensen Huang's framework for how the shift changes work. Now, let's hear Satya Nadella push it further. What this does to the very structure of a firm.
I think it's actually, you're pulling on a very interesting thread, which is at some level, what's the big structural change that needs to happen? In fact, I would say this is probably the biggest change in knowledge work since PCs. I mean, I always think about like how did work happen pre-PCs, right? I mean, think about a multinational company like ours trying to do a forecast, right? Faxes went around, inter-office memos got sent, and then you kind of created a forecast. Then suddenly, PCs became standard issue. You put an Excel spreadsheet, put some numbers, sent it in email, everybody entered numbers, and you had a forecast. So the work artifact and the workflow all changed. That's what's happening. So for example, I'll give you, at LinkedIn, we used to have product managers, we had designers, we had front-end engineers, and then we had back-end engineers and so on. So what we did is we sort of took those first four roles and combined them. In fact, increased scope and said, they're all full-stack builders. So I like that because that's a structural change that allows for us to change both the work and the workflow between these functions.
And I would assume the velocity, because you don't have four people communicating and that throughput of ideas, it's just one person and vibe coding.
Exactly. And there's a new workflow. So at the same time, as you can imagine, if to build an AI product today, there's a complete new workflow, right? It starts with evals, right? So basically there's this eval to science to infrastructure. And so evals are done by these full stack builders and what have you, and product managers in the new form. The infrastructure is built by the systems engineers at the back end because they support the science that supports the product. So in some sense, there's a new loop
Yes.
and you have to structurally change. And so a lot of what is happening inside of tech is that change, which is, I think, going to be pretty massive.
This next point is an identity level challenge. If you lead a team or just want to be impossible to replace, listen for what it means to turn what you know into something you control.
A firm should be able to take the tacit knowledge it has and embed it inside a weights in a model that they control. Right? So when somebody asks me how many models should be there, I'll say as many models as firms in the world. Right? That's sort of an extreme way. Because to me, that's how I think this knowledge economy becomes an AI economy.
Are you
mean? Like, for example, in the AI era, the topic that's least talked about, but I feel will be most talked about in this calendar year, will be the sovereignty of a firm. Just imagine, if your firm, you're not able to embed the tacit knowledge of the firm in a set of weights in a model that you control, by definition, you have no sovereignty. That means you're leaking enterprise value to some model company somewhere. In fact, it's sort of fascinating that nobody's talking about that, right? It's like everybody's talking about everything else that is sort of, outside of that. Whereas the most important thing is, it really doesn't matter if in fact, the data center, where it runs, is the least important thing, quite honestly. But like even there, first of all, the data centers are all over just because speed of light is a real constraint. And so therefore, the data centers will be spread.
Yes.
You will have digital, you'll be able to encrypt everything, you'll be able to have the keys with you. All of these are much more technically solved problems. But the one problem that will only be solved is by you having much more sovereignty over the tacit knowledge and control over the models, and it's not a one-way enterprise value transfer. And so to me, I think sovereignty requires real thought on what is it. Control of destiny means that your ability to produce something that is unique is preserved. David Ricardo was not wrong. There's comparisons, right? One is, to us, the most important thing, when I look at what is Microsoft's strategy today, one is we want to build token factories, right? So our biggest business today is Azure business, and the Azure business, the TAM, given what's going to happen, is so huge that we now need to be fantastic at building these token factories. And that means a heterogeneous fleet of infrastructure, and that every hyperscaler has always done, which is use software to make maximum use of it and for TCO and utilization. So that's one side of it. Then there's the app server business, right? Which is you talked about, like, if everyone's going to be building agents, have infinite minds, have these RL gyms, have evals, what have you. There's an entire, just like every platform has had an app server, this one has an app server. That's what we're doing with Foundry and what have you, right? So there's an app server business. In that app server, one of the things that structurally now is pretty clear is anyone building any application or any company is going to use not one model, but all the models, right? Why would I not, right? Which is, in fact, I will orchestrate for any given task, even multiple models, right? There's this one nice thing that we came out in our healthcare practice called the decision orchestrator. What it proves is that by assigning roles, right? So investigator, data analyst, domain expert, just giving even prompted roles to models and then orchestrating them gets better results than any one single frontier model.
Am I right?
We're going to zoom out again because your personal AI strategy still runs into a very physical limit. And it's not creativity, it's power.
When you think about AI, you think about the AI models. But it's really important to understand industrially, AI is actually essentially a 5-layer cake. At the bottom is energy. AI, because it's processed in real time and it generates intelligence in real time, it needs energy to do so. Energy is the first layer. The second layer is the layer that I live in. It's chips. Chips and computing infrastructure. The next layer above it is the cloud infrastructure, the cloud services. The layer above that is the AI models. This is where most people think AI is. But don't forget that in order for those models to happen, you have to have all of the layers underneath it. But the most important layer, and this is the layer that's happening right now, the reason why last year was an incredible year, frankly, for AI, is that the AI models made so much progress that the layer above it, which is ultimately the layer that we all need to succeed, the application layer above that. And so this application layer could be in financial services, it could be in healthcare, it could be in manufacturing. This layer on top ultimately is where economic benefit will happen. But the important thing, though, because this computing platform requires all of the layers underneath it, it has started, and everybody's seeing it right now, it has started the largest infrastructure build out in human history. We're now a few $100 billion into it.
That's it.
We're a few $100 billion into it. Larry and I, we get the opportunity to work on many projects together. There are trillions of dollars of infrastructure that needs to be built out. And it's sensible. It's sensible because all of these contexts have to be processed so that the AI, so that the models can generate the intelligence necessary to power the applications that ultimately sit on top. And so when you go back and when you reason about it layer by layer by layer, and you realize that the energy sector is now seeing extraordinary growth. The chip sector, TSMC just announced they're going to build 20 new chip plants. Foxconn working with us and Wistron and Quanta building 30 new computer plants, which then go into these AI factories. So we have chip factories, computer factories, and AI factories all being built around the world.
And memory.
And memory, right, exactly. Those chip.
The limiting factor, I think the limiting factor for AI deployment is fundamentally electrical power.
It's right, it's energy.
Yeah. I mean, we're seeing the rate of AI chip production increase exponentially, but the rate of electricity being brought online is
3%, 4% a year, max.
Yeah. It's clear that we're very soon, maybe even later this year, we'll be producing more chips than we can turn on. except for China. China's growth in electricity is tremendous.
They're building 100 gigawatts of nuclear as we speak.
So net effect is that the lowest cost place to put AI will be space, and that'll be true within 2 years, maybe three at the latest.
Now we move from can we build it to what happens when it spreads. Because the biggest winners aren't always the inventors. They're the fastest adopters.
And that's why one of the things we'll be doing with SpaceX within a few years is launching solar-powered AI satellites.
Right.
Because the space is really the source of immense power, and then you don't need to take up any room on Earth. There's so much room in space, and you can scale to enormous. You can scale to, I think, ultimately hundreds of terawatts a year.
First of all, this is the largest infrastructure build-out in human history. Yep. That's going to create a lot of jobs, and it's wonderful that the jobs are related to tradecraft, and we're going to have plumbers and electricians and construction and steel workers and network technicians and people who install and fit out the equipment, and all of these jobs. We're going to, in the United States, we're seeing quite a significant boom in this area. Salaries have gone up, nearly doubled. Yeah. And so we're talking about six-figure salaries for people who are building chip factories or computer factories or AI factories. And we have a great shortage in that. And I'm really delighted to see so many people in so many countries really recognizing this important area. Everybody should be able to make a great living. You don't need to have a PhD in computer science to do so.
I mean, I think how we think about that is, as we've built better and better models, there's been a kind of exponential relationship, not only between how much compute you put into the model and how cognitively capable it is, but between how cognitively capable it is and how much revenue it's able to generate. So our revenue's grown 10x in the last 3 years, from 0 to 100 million in 2023, 100 million to $1 billion in 2024, and 1 billion to 10 billion in 2025. And so those revenue numbers, I don't know if that curve will literally continue. It would be crazy if it did. But those numbers are starting to get not too far from, the scale of the largest companies in the world. So there's always uncertainty. We're trying to bootstrap this from nothing. It's a crazy thing. But I have confidence that if we're able to produce the best models in the things that we focus on, then I think things will go well. And
so many people talk about there may be an AI bubble. I mean, the most important thing that we see as an investor is the democratization of technology, and the diffusion of that technology really does then transform the demand. And the companies or the countries that diffuse it fastest are going to be the ultimate winners, not the technology creator.
For this not to be a bubble,
yep,
by definition, it requires that the benefits of this are much more evenly spread. I mean, I think a telltale sign of if it's a bubble would be if all we're talking about are the tech firms, right? If all we talk about is what's happening to the technology side, then that's it's just purely supply side.
Right.
Ultimately, if we are not talking about, wow, here is a drug that was sort of brought into the market that's super successful because it was AI accelerated the clinical trial. It's not even the magical molecule, right? It's kind of even the rest of what is needed in order to make something much more relevant, right? And so the more we have. And by the way, it's happening, right? So I'm not sort of saying that. That's why I'm much more confident that this is a technology that will, in fact, build on the rails of cloud and mobile, diffuse faster, yep, and bend the productivity curve and bring local surplus and economic growth all around the world, not just economic growth driven by capital expenses, right? Because it's a narrow point in time calculation. It's
right now, that's what.
No, absolutely. In fact, what you all have been doing to make sure, in this context, the American tech stack is broadly used around the world and is trusted around the world. Because I think when I look back, David, to me, at the end of the day, you create the technology, but really the benefits come only by intense use. In fact, one of my favorite studies has always been this work that an economist, I think out of Dartmouth, did. His name is Diego Comen, where he studied basically what happened during the Industrial Revolution. How did countries get ahead? And the simple sort of takeaway from that was any country that brought the latest technology into their country and then did value-add technology on top of it, right? So it's like, don't reinvent the wheel, bring the latest, and then build on top of it. That's, to me, what happens, when you have diffusion. So especially with general-purpose technology like AI, it needs to spread. Like right in our own country, in the United States, we have the tech. The question is it being used in healthcare? Is it being used in financial services? Is it being used in every sector of the economy by large businesses, small business, public sector? So to me, unless and until we see that diffusion and intense use, we're not going to have the success. And so that's the phase we are in. It's diffusing faster.
Well, first of all, AI is infrastructure, and there's not one country in the world I can't imagine that you need to have AI as part of your infrastructure, because every country has its electricity, you have your roads. You should have AI as part of your infrastructure. Of course, you could always import AI, but AI is not so incredibly hard to train these days, and because there are so many open models, these open models with your local expertise, you should be able to create models that are helpful to your own country. And so I really believe that every country should get involved to build AI infrastructure, build your own AI, take advantage of your fundamental natural resource, which is your language and culture, develop your AI, continue to refine it, and have your national intelligence be part of your ecosystem. And so I think that's number one. And number two, remember, AI is super easy to use. It's the easiest software to use in history, and that's the reason why it's the fastest growing and most rapidly adopted. I mean, in just a couple of 2-3 years, it's coming up to almost a billion people. I think, first of all, Claude is incredible. Anthropic has made a huge progress, huge leap in developing Claude. Yep. We use it all over our company. The coding capability of Claude, its reasoning capability, its ability is just really incredible. And anybody who's a software company really ought to get involved and use it. On the other hand, ChatGPT is probably the most successful consumer AI in history. And its ease of use and its approachability, I think everybody should get involved. And whether it's somebody in a developing country or a student, it is very clear that it is essential to learn how to use AI, how to direct an AI, how to prompt an AI, how to manage an AI, how to guardrail the AI, evaluate the AI. These skills are no different than leading people, managing people, things that you and I do all the time. So in the future, instead of biological, carbon-based AIs, in the future we're also going to have digital versions of AIs, silicon versions of AIs, and we'll have to manage them. They're just part of our digital workforce, if you will. And so I would advocate that for the developing countries, build your infrastructure, get engaged in AI, and recognize that AI is likely to close the technology divide.
Right.
Because it is so easy to use and so abundant and so accessible. And so, I'm actually fairly optimistic about the potential of AI to lift the countries that are emerging, and for many people who haven't had computer science degree, all of you can be programmers now, And so in the past we had to learn how to program a computer. Now you program a computer by saying to the computer, "How do I program you?" And if you don't know how to use an AI, just go up to the AI and say, "I don't know how to use an AI. How do I use an AI?" And it would explain it to you. And you say, I like to write a program to create my own website. How do I do that? And it would ask you a whole bunch of questions about what kind of website you would like to build, and then write you the code. And so it is that easy to use, and that's, of course, the incredible power of AI, which is exciting.
That's right. So in fact, one of the demos I always go back to, I think this was even in the beginning of 23, was a rural Indian farmer was able to use a bot built on, I think, a very early GPT-3 or 2.5 even, essentially to reason over some farm subsidies that he had heard about in a local language, and had it even in that very early days have it even show some agentic behavior, right? Like, go complete a form for me. So in some sense, it took, it brought back agency to someone who perhaps didn't have that because the technology was so much more accessible. Right. So I do think of AI. He said either it's a cognitive amplifier or it's a guardian angel, right? So if you think of AI as that, then in the global workforce, right, when a doctor can get to a patient, spend more time with the patient because the AI is doing the transcription and entering the records in the EMR system, entering the right billing code so that the healthcare industry is better served across the payer, the provider, and the patient ultimately. Right? That's an outcome that I think all of us can benefit from. So I feel ultimately it's going to require real leadership on the private sector and the public sector to ensure that diffusion happens. And the other thing I'll mention, Larry, is skilling, right? So in some sense, the thing that diffusion is very strongly correlated to one thing alone, which is how broadly are people skilled in using this. And interestingly enough, I think if mobile has taught us one thing, is it's actually distinct from what happened in the PC, right? I remember even growing up in the global south, there used to be a real relationship between learning Excel skills or Word skills and getting a job. Right now, what's the model? In mobile, it's kind of created the same opportunity, but it's been a lot more consumption-led. It's these creator economy and what have you. But it has not been about sort of, oh, wow, here is how you get a healthcare job, or here is how you get a finance job, or here is how you get, you get ahead professionally. And that needs to come back, right? People need to say, oh, I pick up this AI skill, and now I'm a better provider of some product or service in the real economy.
Up to now, it sounds like acceleration is inevitable. But here's the friction point. Today's systems aren't uniformly reliable, so your advantage comes from knowing what to delegate and what to keep.
Whereas now, I just go to Copilot and say, hey, I'm meeting Larry, please give me a brief. And it comes back and gives me, by the way, the one nice thing is it gives me a 360, right? It knows what we are doing with you as a client, what we're doing as a client of yours, right, and everything in between as an investment. So it captures even information unlike anything else. In fact, what I do is I take that and immediately share that back with all my colleagues across all the functions, right? Think about it. It's a complete inversion of how information is flowing in the organization. It's not like this classic, we have an organization, we have departments, we have these specializations, and the information trickles up. No. It actually, it flattens the entire information flow. So once you start having that, you have to redesign structurally. So the current structure may not make sense because you want people to be able to work in a way that allows them to have this information flow freely. So what all this leads me to, if I had to sort of say what's the formula, I think it starts with the mindset. So the mindset we as leaders should have is we need to think about changing the workflow with the technology. Then that needs skill set. So you can't sort of talk about this in the abstract. You got to use it. Like, so if I'm not using the tool,
you have to trust it.
You have to trust it. You have to use it. You have to learn even how to put the guardrails to trust it, right? So you can't just be afraid of it. It's going to be diffused. So the question is, as a firm, you have to use it to learn how to even put the guardrails that allow you to be able to trust it. Yeah, so I think one of the most perhaps illustrative examples of trying to understand these various form factors is looking at coding, which is obviously a form of knowledge work, or probably the best example of knowledge work. And if you think about the journey coding has been, it started with essentially the next edit suggest, right? That was the first time, in fact, my own belief in this entire generation of tech really sort of got formulated when I started seeing, I think this, there's a codex model back in the day, it was pre-GPT 3.5. That's when next edit suggestions started working with some real accuracy. Then we went to chat, then we went to actions, and now to full autonomous agents. And then the autonomous agents can be both foreground, background, in the cloud, or local, right? So that's all the form factors that exist today when you're coding. And interestingly enough, if you look at it, you use all of them, right? It's not like there's only one form factor. So that's, I think, probably one of the other lessons. So for example, when I'm in a CLI, you go a foreground agent, background agent, and then just literally go edit in VS Code right there, all happening in parallel, right? So that sort of shows how these form factors even compose. To your point, we started with chat. Chat with reasoning sort of goes beyond just request response, because you now have that chain of thought where you can see it work. Now there are actions, right? Essentially either through computer use or through basically skills and agent calls, so you can do actions. So that's kind of the state of the Copilot today. Now, there is a way to think about the theory of the mind evolution, right? Because you need, like, if you remember, Jobs had the best line, I would say, for PCs or computers was to say, it's a bicycle for the mind. Bill had a line which I liked as well, which was, it's information at your fingertips. We kind of need now a new concept, metaphor, for how we use computers in the AI age. And
you have one?
And the one I like actually came from the CEO of Notion, which I like, that manager of...
Incredible product.
Yeah.
You haven't bought it yet.
I've not bought that. But it's both management of, basically a manager of infinite minds. That's a nice way to think about it, right? When you sort of really look at all the agents that you are working with, you kind of need to understand in fact, the other term I like is we macro delegate and micro steer. In fact, you kind of need that. In coding, you kind of have it, right? So you do a macro delegation, and then I can in parallel give it instructions while it is doing work. Then I think you bring up one more thing, which is, can you create quote-unquote digital employees, digital co-workers, or what have you? And it's all about credentials, right? So today you can literally assign...
Are you working on that as well?
Yeah. So in fact, we introduced something called Agent 365 as a way to give identities. In fact, extending the identities we have for humans today and the endpoint protection we have for their compute devices to agents. So
you might clone me working in the HR department or working in the marketing department and have a virtual version of me inside of Office.
That's correct. So there are two sort of modalities there. One is you give every knowledge worker infinite minds. That's kind of one. And then you create even infinite minds independent of your identity, because the identity is one of the key things you got to get right, even for it to work, right? So
for permissions and decision making.
Permissions, decision making, and like one of the key things is who did what to whom is sort of the most important query in an organization, right? At the end of the day, the organization needs to understand what work got done and what's the provenance of that work, and how do you trace it back, right? So therefore, you kind of want if it's a human with a lot of agents, then it's really macro delegation, micro steering by the human whose identity was passed on.
And I call it jagged intelligences. We're very good at certain things, and it's very poor, the current systems, at other things. And if you want to offload or delegate an entire task to, say, an agent, rather than having what we have today, which are more like assisted programs, you're going to need a lot more consistency across the board. It's no good for it to be good at 95% of that task. You need it to be good at the whole task for you to be able to actually just sort of fire and forget on it. So I think there's still quite a lot more to be done before we'll see that kind of disruption.
But that kind of disruption will happen.
I think eventually, sure. I mean, in the limit with AGI, if you have systems like that, I think that changes the whole economy, actually. It's way beyond the question of jobs. I think potentially if we build it right, we're in a post-scarcity world where we've solved some of the kind of fundamental root nodes of the world, like energy sources, new, clean, renewable, basically free energy sources. If we solve fusion, something like that, with the help of AI, new materials, I think we'll be, 5-10 years past AGI, we'll be in a radical, abundant world. And yeah, I spent a lot of the last year actually looking very carefully into robotics. I do think we're on the cusp of a kind of breakthrough moment in physical intelligence. I still think we're about 18 months, 2 years away from we need to do more research, but I think the foundation models like Gemini show the way forward. I mean, from the beginning, we made Gemini multimodal, so it could understand the physical world for multiple reasons. One was so we could build a universal assistant, maybe that exists on your glasses or your phone that understands the world around you. But of course, a second use of that would be for robotics.
So what does that moment for the physical world look like?
I think it's having robots, reliably do useful tasks out in the world. And I think there's a few things holding that back still. Part of it is the algorithms are still not quite there. They need a little bit more robustness. They have to work with less data than you get for the LLMs or the models that work on just digital realm. You can sort of create synthetic data. It's a lot harder to make that kind of data. And there's still sort of some problems in the hardware that are not solved, specifically things like the arm and the hand. Actually, when you look into robotics very carefully, you get a newfound appreciation, at least I did, for the human hand and how exquisite evolution has designed that. It's incredible. And it's very hard to match the reliability, the strength, and the dexterity that the human hand has. So there's still quite a lot, in my opinion, pieces that put together, but there's very exciting things. I mean, we just announced a new deep collaboration with Boston Dynamics. They've got some very exciting robots in Hyundai and actually applying it to automotive manufacturing. And we'll see over the next year how that goes in sort of prototype form. And then maybe in a year or two, we'll have some really impressive demonstrations that we can scale up.
So with robotics and AI, this is really the path to abundance for all. If you say, people often talk about solving global poverty, or essentially how do we give everyone a very high standard of living. I think the only way to do this is AI and robotics, which doesn't mean that it is without its issues. I mean, we need to be very careful with AI. We need to be very careful with robotics. We don't want to find ourselves in a James Cameron movie, Terminator. He's got great movies, love his movies, but we don't want to be in Terminator, obviously. But if you have ubiquitous AI that is essentially free or close to it, and ubiquitous robotics, then you will have an explosion in the global economy, an expansion in the global economy that is truly beyond all precedent. Both. You can't have work that has to be done and amazing abundance for all. Because if it's work that has to be done, then you and only some people can do it, then you can't have abundance.
Then
for
it's
all.
narrow.
It's narrow. Yeah. Exactly. So. But if you have billions of humanoid robots, and I think there will be, I think everyone on Earth is going to have one and going to want one, because who wouldn't want a robot to, assuming it's very safe, watch over your kids, take care of your pet. If you have elderly parents, a lot of friends of mine have said they have elderly parents. It's very difficult to take care of them.
Expensive.
Yeah, it's expensive, and there just aren't enough people to take care of there aren't enough young people to take care of the old people.
Right.
So if you had a robot that could take care of and protect an elderly parent, I think that would be great. That would be an amazing thing to have. I think we will have those things. So, humanoid robotics will advance very quickly. I think we do have some of the Tesla Optimus robots doing simple tasks in the factory. We accept probably later this year. By the end of this year, I think they'll be doing more complex tasks, but still deployed in an industrial environment. And probably sometime next year, I'd say that by the end of next year, I think would be selling humanoid robots to the public. That's when we are confident that it's very high reliability, very high safety, and the range of functionality is also very high. You can basically ask it to do anything you'd like.
With that, if you kind of, connect this to what I said before, which is, we might have AI that's better than humans at everything in, maybe 1 to 2 years, maybe a little longer than that. Those don't seem to line up. The reason is that there's this lag and there's this replacement thing, right? I know that the labor market is adaptable, right? It's just like, 80% of people used to do farming. Farming got automated, and then they became factory workers and then knowledge workers. So, there is some level of adaptability here as well, right? We should be economically sophisticated about how the labor market works. But my worry is as this exponential keeps compounding, and I don't think it's going to take that long, again, somewhere between a year and 5 years, it will overwhelm our ability to adapt. I think I made...
This is the reframe that makes AI usable for you, not as hype, not as fear, but as leverage. Listen for the mental model you can carry into your next week of work.
I sometimes talk about setting up an international CERN equivalent for AI, where all the best minds in the world would collaborate together and do the final steps in a very rigorous scientific way, involving all of society, maybe philosophers and social scientists and economists, as well as technologists, to kind of figure out what we want from this technology and how to utilize it in a way that benefits all of humanity. And I think that's what's at stake. Unfortunately, it kind of needs international collaboration, though, because even if one company or even one nation or even the West decided to do that, it has no use unless the whole world agrees, at least on some kind of minimum standards. And, international cooperation's a little bit tricky at the moment. So that's going to have to change if we want to have that kind of rigorous scientific approach to the final steps to AGI.
So if AGI comes in, let's say, 2030, we don't have the regulations set up yet. Are we?
Right. We pioneered this idea of mechanistic interpretability, which is looking inside the model and trying to understand, looking inside its brain, trying to understand why it does what it does. As human neuroscientists, which we actually both have background in, try to understand the brain. And I think as time has gone on, we've increasingly documented the bad behaviors of the models when they emerge, and are now working on trying to address them with mechanistic interpretability. So I think I've always been concerned about these risks. I've talked to Demis many times. I think he has also been concerned about these risks. I think I have definitely been, and I would guess Demis as well, although I'll let him speak for himself, skeptical of doomerism, which is, we're doomed, there's nothing we can do, or this is the most likely outcome. I think this is a risk. This is a risk that if we all work together, we can address. We can learn through science to properly, control and direct these creations that we're building. But if we build them poorly, if we go, if we're all racing and we go so fast that there's no guardrails, then I think there is risk of something going wrong.
So
and just to say a word about the problem here, you've got 1,200 bills right now going through state legislatures to regulate AI. Right. It's a little bit of a knee-jerk reaction. And regardless, you've got 50 states running in 50 different directions. That's going to create a patchwork problem. The big tech companies are always going to be able to figure out how to comply because they have so many lawyers. But for our small tech companies, our startups, our entrepreneurs, that's going to be a huge compliance burden. Imagine if, in order to create a startup, you now have to hire lawyers in 50 different states.
Right, we don't want that.
Yeah,
don't want
that's
that.
the thing we want to
What we've
solve.
seen with social media, though, is that it was never fully regulated because there wasn't some way to kind of get at it. And so it's always been kind of self-enforcement by the companies themselves. And that doesn't always work brilliantly.
Yeah, and what we've heard from Capitol Hill is that you can't replace something with nothing. So the idea of preempting the states without having a replacement, not going to work, but we're going to try and see if we can come up with a consensus view, with the Hill on let's call it a lightweight legislative framework for AI.
Right. If this was telecom or something, then all this stuff about proliferating the U.S. stack and, wanting to build our, chips around the world to make sure that, these random countries in different parts of the world, build data centers that have NVIDIA chips instead of Huawei chips. I think of this more as like, it's a decision. Are we going to, sell nuclear weapons to North Korea? And, because that produces some profit for Boeing, where we can say, okay, yeah, these cases were made by Boeing, like the U.S. is winning, like this is great. Like I just, that analogy should just make clear how I see this trade-off, that I just don't think it makes sense.
From NVIDIA, and there's been a big question about whether their chips should be sold to China, how they should be sold. It seemed like they were going to be allowed, then they weren't going to be allowed, then they were. It's gone back and forth. And I just want to, if you can explain to the viewers what your actual thinking is on this topic, what it really, are you worried about the security? Are you worried about them having too much access? Are you thinking if we get these chips out there, that'll actually, from a competitive perspective, sort of push out the Huawei's of the world? What is the actual sort of strategy behind the White House's view on this?
Well, the latest reporting is that China doesn't want the chips.
Right.
They're not going to let the
That's the next, right. So here we are. We've had this.
Yeah. So there's this huge controversy over here about whether we should sell them to China, and then China's saying they don't want them. The reason China doesn't want them is because they want to indigenize chip production. They want to have their own chip industry, and specifically they want Huawei to be the national champion. Now, you asked about our thinking, which is if we can sell a previous generation deprecated chip into the Chinese market and take market share away from Huawei and prevent their scale up, we think there's some value in that. But I think this issue is going to be largely moot because China sees the same thing we do.
And you think it's just...
Well, like, do you ever feel comfortable?
No, you never feel comfortable. I mean, we try, code reds are for very special circumstances, but it's always, for the last, I would say, 3-4 years, it's been unbelievably intense. And, 100-hour weeks, 50 weeks a year, and that's the norm. And I think that's what you have to do at the forefront of this unbelievably fast-moving technology. It's ferociously competitive out there, maybe the most intense competition there's ever been in technology, and the stakes are incredibly high, AGI and all of that can mean. So commercially, scientifically, and then if you add all the excitement of what we're doing and, using it as my passion, as you know, is exploring scientific, problems with AI, accelerating scientific discovery itself.
Global South. I think Global South has a huge opportunity too, quite frankly, because to me, like, let's say, 40%, 50% of the GDP of most Global South countries is public sector. So just imagine this tech making a difference in how the governments really parlay the taxpayer money into services for citizens. And if there's efficiency gains, that's probably a couple of points of GDP growth right there.
Well, they're all very difficult technology challenges, but the overall goal of my companies is to maximize the future of civilization, like basically maximize the probability that civilization has a great future, and to expand consciousness beyond Earth. So if you take SpaceX, for example, that SpaceX is about advancing rocket technology to the point where we can extend life and consciousness beyond Earth, to the moon, to Mars, eventually to other star systems. And I think we should always view consciousness, life as we know it, as precarious and delicate, because to the best of our knowledge, we don't know of life anywhere else. I'm often asked, are there aliens among us? And I'll say that I am one, but...
Or you're from the future.
They don't believe me.
Okay.
But I think if anyone would know if there are aliens among us, it would be me. And we have 9,000 satellites up there, and not once have we had to maneuver around an alien spaceship. So I'm like, I don't know. Bottom line is, I think we need to assume that life and consciousness is extremely rare, and it might only be us. And if that's the case, then we need to do everything possible to ensure that the light of consciousness is not extinguished, because we're effectively, the way I view it is, the image in my mind is of a tiny candle in a vast darkness, a tiny candle of consciousness that could easily go out. And that's why it's important to make life multiplanetary, such that if there is a natural disaster or a man-made disaster on Earth, that consciousness continues. That's the purpose.
Then the demand side of this is a little bit like every firm has to start by using it. If I look back even, when the PCs first came out or the personal computing era started, I loved, I think Jobs had a nice metaphor. He called it the bicycle for the mind. Bill had a metaphor which I remember was like information at your fingertips, right? These two metaphors were great, which allowed us to say, that's what it is. It's a tool that I will use to get information at my fingertips. I'll use it as a cognitive amplifier. Now, I think that's what we have, but 10x, 100x, right? So in some sense, you, as every knowledge worker, you now have access to infinite minds. That's the way I think about it, right? So there's a...
But I think some areas of kind of engineering work, coding, also you could say mathematics, are a little bit easier to see how they would be automated, partly because they're verifiable what the output is. Some areas of natural science are much harder to do than that. You won't necessarily know if the chemical compound you've built or this prediction about physics is correct. You may have to test it experimentally, and that will all take longer. So I also think there are some missing capabilities at the moment in terms of not just solving existing conjectures or existing problems, but actually coming up with the question in the first place or coming up with the theory or the hypothesis. I think that's much, much harder. And I think that's the highest level of scientific creativity. And it's not clear. I think we will have those systems. So I don't think it's impossible. But I think there may be one or two missing ingredients. It remains to be seen how, first of all, can this self-improvement loop that we're all working on actually close without a human in the loop? I think there are also risks to that kind of system, by the way, which we should discuss, absolutely, and I'm sure we will. But but that could speed things up if that kind of system does work.
We'll get to the risks in a minute, but one other...
Here's your challenge. Stop treating AI like news and start treating it like training. Pick one part of your work where speed and quality matter: writing, analysis, planning, outreach, learning, and build a repeatable system this week. Don't aim to use AI. Aim to become the person who can direct it, verify it, and ship with it. If you want more episodes like this, big ideas, hard questions, and frameworks you can act on, subscribe and tell me in the comments, what's the one skill you're upgrading so you stay valuable no matter how fast this moves?